Hi guys, so today we're going to look at row operations for a matrix in order to get a matrix into row echelon form and reduced row echelon form. So before we start, we need to know what an augmented matrix is, and all that is a 3x4 matrix. Well, for a 3x3 system, it's a 3x4 matrix that has the coefficients of our variables, and then the last column is going to consist of those numbers on the other side of the equal sign. So very similar to the matrices we were using for inverses, except we're going to combine it into one matrix. So our augmented matrix here is going to have our variable or our coefficients. If there is a variable that's not on there, we need to fill in the 0. And then the notation you typically see for this, at this point you'll still have those numbers, because it is just a 3x4 matrix, but you'll typically see a line or a dotted line or some colons or something basically to just differentiate the fact that that last column aren't coefficients of your variables. So you'll see a couple different notations, and if you don't write one, that's okay, but that's typically just how we'll see it. So let's go ahead and write the augmented matrix for B. So this is going to be 1, -6, 0, 5. 0 x's, and then I'm going to go ahead and draw that line to show where my variables stop. All right, so what we're going to do is we're going to use that augmented matrix in order to get this matrix in what's called row echelon form. So row echelon form is something that's in this form right here. So what's important out of this is basically we want this bottom triangle to be zeros, and we want this diagonal to be 1s. The other numbers, they can be anything, does not matter what, but what this will do is this is going to create a system that's really easy to solve via substitution. Now, what you were allowed to do to get it in that form, there were 3 different things that you can do. You can swap out 2 rows. So let's say, for example, your top row was in this form and your bottom row was like this. You could go ahead and just switch those rows places. Okay, so that's one option. Option 2 is you can multiply a row by a constant. So you can take a row and you can multiply every number in that row by 2. Or you can multiply every number in that row by -1/2. Then your last option is you can add a multiple of a row to another row. So you can add 2 rows together, but you also could add like 2 times that row. All right, so let's start with this first example. We're going to go ahead and write our augmented matrix first. Now with these, there's different ways for you to solve them. You don't have to solve them the exact way that I'm doing it. I'm just going to go and do these a certain way that makes sense to me. If you find an easier way to do it, you're welcome to do it that way. If you find a longer way that's just easier for you to get to, then that will work. Again, our goal eventually is just to have that bottom triangle of zeros. So again, we can add or subtract rows, we can add or subtract multiples of rows, or we can multiply by constants. Keep in mind, if we're trying to get zeros, multiplying by a constant is not going to get us to that 0 value. So let's go ahead and start. Typically what I like to do when I'm working these out is I want to start by getting one of my zeros, because those tend to make the rest of our steps a little bit easier. So I'm going to start by taking the second row and adding the first row to it. So I'm going to keep the first row the same. So my first row is not changing. And then I'm going to add the first row to the second row. So -1 plus 1 is now 0. 3 plus -2 is now 1. 0 plus 3 is 3. -4 plus 9 is 5. My bottom row also has not changed. All right, so now that I've done that, I'm going to go ahead and do another operation here. So this is a good start because now I have one of those zeros in the far left column. So then at this point, what I'm going to do is I'm going to look at the bottom row, and I'm going to want to try and make that one also a 0, because I'm going to need 2 zeros out of this. So what I'm going to do here then is I'm going to subtract 2 times row 1. So if I do that, Then I would do 2 minus 2 times 1, which is 0. Negative 5 minus 2 times negative 2, which is going to be negative 1. 5 minus 2 times 3, which is going to be negative 1. And then 17 minus 2 times 9, so 17 minus 18, also a negative 1. The other rows did not change. All right, so now I'm in a pretty good place because now I have both of those zeros. So what I'm going to need is I'm going to need one more 0, and I'm going to specifically want to be this one. Now keep in mind, it doesn't have to be that one. It could be this 0, and then you could swap rows. So again, there's more than one way to do this, just depending on whatever is going to make the most sense to you. But what I'm going to do is I'm going to go ahead and get this one to be my 0. And I'm going to do that by adding that second row. Now again, I want to add a multiple of the second row, because if I were to add a multiple of the first row, then that's going to go back and change that 0, which I don't want to do. I already have a 0 there, and I want to keep that there. All right, so let's go ahead and add the second row to the third row. So that's going to change my third row now. So my third row is 0, 0, 2, 4. And then these rows did not change. So now I'm really close to being at the answer I want. The only thing I need to change here now, that needs to be a 1 instead of a 2. And once you get to this point, it's really easy, because your last step, really, all you need to do at this point is multiply by a constant. And I'm going to multiply by 1/2. So I'm going to multiply by 1/2. Again, that's not going to change the top row. And now it's in that row echelon form like we wanted. Now the reason that we like that row echelon form is now if I were to solve this system, it'd be really, really simple, because let me go backwards and write the system of equations that goes with this system. So the system here would be x minus 2y plus 3z equals 9, y plus 3z equals 5, and z equals 2. Well, in order to actually solve this system, I already know what z is. Well, then I can take z and I can plug it in. So y plus 6 equals 5. So now I know what y is. And now that I know what z is and I know what y is, I can take both of those and plug them back into that top equation. So x minus 2 times negative 1 plus 3 times 2 equals 9. And I end up with x equals 1. All right, so if you feel kind of comfortable with this, pause the video and let's just try this next example. It's going to be, again, there is more than one way to do it, so it's possible for you to get that answer without doing it the way that I'm working out. So if you feel comfortable, try this one on your own. Otherwise, I'm going to go ahead and continue. All right, so I'm going to start here with my augmented matrix. So I'm going to have negative 2, negative 3, 3. Okay, and I'm going to start by getting one of my zeros. So to me, I think the easiest 0 to get is going to be a bottom left 0 by adding these two rows together. So what I'm going to do is I'm going to take the third row and I'm going to add row 2. So that's going to give me 0, 0, 4, and 12. All right, so now at this point, again, couple different places you can go. I'm going to go ahead and get that 1, just because it's a pretty easy step at this point. I'm going to go ahead and do 1/4 times this row. So I'll go ahead and rewrite that as 0, 0, 1, 3. The first two rows did not change. All right, so there's my next step. Okay, so now at this point, I need to get a 0 out of one of those two. It does not matter, again, which one, because you can always swap the rows at the end, but I'm going to go ahead and keep it at the place that it is. So what I'm going to do then, I can either go ahead and try and get this 0 now by multiplying by a certain constant, or what I'm going to do, just to what I think is going to be a little bit simpler, I'm going to go ahead and get that 1 in the top left. That way I can use that in relation to my second row later on. They'll keep me with a little bit less of my fractions. So I'm going to go ahead and do -1/2 times this row. So basically I'm going to divide each of those values by 2. So that gives me 1, -1/2, -3/2, and -10. The bottom two rows did not change. All right, so now that I have that 1, I think it's going to be a little bit easier to get that next 0. Because what I can do now is I can just add 3 times R1. So if I do that, that's going to give me, again, -3 plus 3 would be 0. 2 plus -3/2 is going to be 1/2. 1 plus -9/2 is going to be -7/2. And then 21 plus -30 is going to be a -9. The other rows did not change. So now at this point, there's only one last thing I need to do. I need to turn that 1/2 into a 1. So I'm going to do 2 times R2. So now I have 1, -7, -18. And now it's in row echelon form. So again, if I wanted to go ahead and solve this now, so I'm going to write the system that corresponds. So x minus 1/2 y minus 3/2z equals -10. Then I have y minus 7z equals -18, and z equals 3. So z equals 3, y minus 21 equals 18, so y is going to equal 3. And then if I solve my last equation, I've got x minus 3/2 minus 9/2 equals -10. So x minus 12/2, so minus 6. So I get that x equals -4. All right, so that's, again, using row echelon form. Now what you also can do is you can take this one step farther and use something called Gauss-Jordan elimination, and that is going to be put our matrix in what's called reduced row echelon form. We start in a very similar place. We're basically going to continue the previous example, and what we're going to do instead now, our goal is, instead of making it look like where we only have that bottom triangle of zeros, we also have a top triangle of zeros. So really it's going to look like the identity matrix with our solutions on the other side. Now once you get to row echelon form, it's really easy to get to reduced row echelon form from that. All right, so what we're going to do is we're going to continue example A. So I'm going to go back to example A, and I'm going to write my row echelon form that we came up with. So what we came up with was 1, 0, 0, 0, 1, 1. So this was my row echelon form from example A. So what I'm going to do is I'm going to continue this so that I can put it in Gauss-Jordan, or use Gauss-Jordan to put this in reduced row echelon form. So what I'm going to do, again, I'm going to go ahead and try and get this 0. Well, in order to get that 0, I'm going to want to base that off of this bottom row. I don't want to use the top row because then it's going to change the 0 that I already have. Using that bottom row is going to be a lot easier because then the zeros aren't going to impact the values that I already have. So what I'm going to do then for my operation here is I'm going to go ahead and take this second row and I'm going to subtract 3 times row 3. So that would be 0 minus 0, 1 minus 0, 3 minus 3, then 5 minus 2 times 3, so 5 minus 6 is negative 1. The top row and the bottom row have not changed. All right, so now my second row looks good. So now I need to do an operation to the top row. So I need to subtract, or I should add, 2 times row 2. Because again, now that these are both zeros, it's not going to change the first number, which I really want, or don't want to change. But if I do 2 times that, that's going to be able to turn that into a 0. So this is going to become 1 plus 0, negative 2 plus 2, 3 plus 0, then 9 plus 2 times negative 1 is 7. The other values have not changed. And then I just need one more operation to get this in that final form. So I'm going to take that top row, and then again, I'm going to subtract 3 times row 3. So this is going to be 1, 0, 3 minus 3. And that was not a 12. That was a 2. That was the line between those. So 7 minus 6 is 1. And then the other 2 rows did not change. And now it's in reduced row echelon form. So then at this point, the thing that's nice about reduced row echelon form, you don't really need to solve a system. It's very obvious what your values are. So x is equal to 1, y is equal to negative 1, and z is equal to 2. What's also nice about reduced row echelon form is that you can also find this on the calculator. So we're going to go ahead and look at our calculator and see how to do reduced row echelon form. All right, so to put this in the calculator, what we're going to do is we're going to do this very similar to the way we found a determinant for our other matrices. So I'm going to go to option, I'm going to go to MAT, and then if you notice, that's where we did our determinant, but we don't see the option we're looking for here. So we're going to do F6, which is that arrow. So now you should see an option. You should see REF and REF. So that's that right there, that is row echelon form. This one right here is reduced row echelon form. So both of those you can do depending on what step you're trying to do. Now typically when you're solving these systems, we're going to use reduced row echelon form more often because that's going to give us our final answer in a much easier to figure out way. So I'm going to do reduced row echelon form, and then I'm just going to enter my augmented matrix. So I'm going to do that by going, I'm going to exit, I'm going to go to Math, MAT, and then I don't see a 3x4 option on here, so I'm going to do M by N and do a 3x4 matrix. So then from here, I'm just going to enter my augmented matrix. All right, so I have my augmented matrix entered, and then when I press enter, that gives me our reduced row echelon form. So then from here, again, I just used the augmented matrix from the original example, but then from here you can see that x is going to equal 1, y is going to equal negative 1, and z equals 2. So this method is probably the fastest way to solve your 3 variable systems. It's probably about the same as doing inverses, but this is a good way to be able to check it. But remember, when we're solving these row echelon type problems, we're going to have to show the steps to get to that final answer. So don't just solely rely on this. Now, when it comes to doing those steps, you also can show those steps on the calculator. Now, again, you'll need to show them on your paper when you write them, but if you need help once we get into some fractions and things, I'm going to show you guys how to actually do those row operations on the calculator. So I'm going to go back to the main screen, and where we see MAT, where I store a matrix. So what I'm going to do is I want to go ahead and store that original augmented matrix. All right, so here is my original augmented matrix. And what I'm going to do is I'm just going to walk through the steps that we did with row operations on the calculator so you could see how to do some of these. Now, if we're keeping them pretty basic, we won't really need to use a calculator. But if you start getting into some fractions and some things that you just want to double check your values, this is a way to do it. So what I'm going to do is I'm going to select row up. And once I select that, I'm going to see the options of the things that I can do to these rows. So I can swap rows, I can multiply a row by a number, I can add a row, or I can add a row, a multiple of a row. So whenever we did this, the first thing we did was we did the second row plus the first row. That was our first step. So in order to do row 1 plus row 2, I'm going to go to row plus, which is F4. So then it says row M plus row N, it goes to the spot of row N. So I want my result to be in row 2. So I'm going to take row 1, I'm going to add row 2, and I want the result to be in row 2. So when I do that, that now looks like the same step that we did. All right, then the next thing we did was we did row 3, and we did our third row, and we subtracted 2 times R1. So the way that's going to look on the calculator is I'm going to do the F3 button. I'm multiplying it by -2. And then I want my result to be in row 3. So I'm doing that K is times row 1. I want it to be in row 3. So now I have that same one that I had in my third step when we were working this out by hand. Then the next step is I did row 3, and I added row 2. So row 3 plus row 2, I can do just row plus F4. I want the result to be in row 3, so I'm going to do 2 plus 3. Then the next step I did was I multiplied that third row by 1/2, so I'm going to do F2, which is times row. I'm multiplying by 1/2. And again, that's going to happen in row 3. So I want M to be 3. I've done that operation, and now I'm in that row echelon form. So that's how you can do some of those on the calculator. Again, you can kind of do a little bit of everything. If you want to swap rows, I can swap row 1 and row 2. Right? If I want to go back, I can swap. Well, now they're switched, but whoops. Okay, and now I'm back to the same form. All right, so the last thing that we're going to look at is just using the calculator to solve this system. Okay, so we're not going to go through all the row operation steps to get to that reduced row echelon form. You will need to do that on several of these, but again, this is just a quick example of how to solve this system with a calculator. So I'm going to find the augmented matrix. So 1, -3, 0, 4. 1, 0, 1, 12, 1, -1, -1, 1. So there's my augmented matrix. I'm going to plug this into the calculator, and I'm going to do reduced row echelon form of that matrix. So go ahead and plug that in your calculator. All right, so I have that augmented matrix plugged in. Once I plug it in, the resulting matrix, that's reduced row echelon form. And from reduced row echelon form, I can see that x equals 7, y equals 1, and z equals 5. So that's a very simple way to be able to solve that system by the calculator. Now again, we're going to do a lot more practice in class next class about how to actually go through these row operations, but these are at least some calculator ways to check your answers.